All right. Welcome back. Good morning. Let me make sure that everything's looking good. Yep. Everything appears to be going well here. All right. Welcome back. It's another beautiful morning. Um, in the previous video, what we worked on was our UV index and sunset sun tracker. Uh, we basically just got the general view for each one of those laid out with the primary elements within each one, and we we laid them out side by side, and we fit their aspect ratios to match and also be 1-to-1 to match the overall design that we have here. What I want to do today is focus on the actual sun tracker piece here. Uh, this is going to be new to me. There's a lot of parts of this that I haven't done either before or in a very long time. It's going to be pretty custom as far as I can tell. And so we're going to fumble through this together. Uh, I think my general approach to this is by looking at this sort of chart graph is that I've got three primary pieces. I've got the main sort of sinusoidal curve. We have the horizontal rule that denotes, I suspect, when the actual sunset and sunrise is. And then we have the uh, dot that represents the sun at its current position in the sky. I don't know. I don't want to spend too much time getting extremely exact with the sun path itself, even with the exact position, because I think a lot of that depends upon like your location and where you are, and I'm going to need a whole lot of data that I just don't have or I would need to research for, and that's not my full goal as part of this project. I really just want to focus on the kind of the core elements that are new to me, especially drawing custom objects like this. I'm not I'm not a meteorologist, not an astronomer, and I'm not a mathematician by any stretch of the imagination. And so, getting the finer details to make this 100% accurate is not something that I'm going to be able to do very quickly. And I don't think it would be very compelling for anyone watching or for myself to actually do. So if that's what you're looking for, if you're looking for an exact, like 100% accurate representation of this, probably not going to be very happy. What I am going to do though is do my best to actually draw this draw this out in a way that at least gives us some parameters to play with to adjust the height of the sinusoid, I guess the amplitude, perhaps the frequency, and then the where this rule sits, where the position of the sun sits, and then being able to style the part that is above the rule in a different color than the rest of the waveform here. So that's my goal. Let's see how much we can get done within. I plan on streaming for an hour and a half. So let's see how much we can get done within that time, and we'll go from there. Cool. So I've done just a little bit of research outside of this video just to get a sense of the approach that I would take here. I did a fast Google for drawing sinusoids with Bezier curves. I've worked a little bit with Bezier curves, rendering Bezier curves in the past, a very, very long time ago. I've never done them in SwiftUI, and so um, this will be really interesting. I found a great resource again in hacking with Swift that that uh, that aligns with sort of the approach I want to take. I What I want to do is create a custom shape object. We can even call it wave that takes in a few parameters to represent like the amplitude and some of the other parts that we want to modify. And then in the path function that we need to implement as part of shape, uh, we can do some quick research on the actual formula that we would want to render this, and effectively, based upon a set resolution that we can pass into it, loop over the resolution points in that curve and draw a like a Bezier path that fits those points. That's the approach I'm going to take, and we'll see how it works out. It'll definitely be interesting. To do this, I'm going to start by creating a brand new file just to sort of play around with this curve in an isolated way. Um, let's call this let's call it wave view for now. I want just sort of a simple playground to be able to test some of this stuff for now. Um, so there's our wave view. I'm going to create an additional struct here, and I'm going to call it wave. I'm going to make it a shape, and we're going to have our func path object that's going to return our path. And for right now, we're just going to draw an empty path. And in our body, I would like to we'll create a VStack, and we'll have our wave here, and let's give it a stroke that's red and a line width of 2. So this is going to be empty for right now. To kind of test it out, just to make sure everything's laying out correctly, like one thing we could do is let's just give it a dummy path that's going to render the path of a rounded rectangle with a corner radius of 2. And we can see here that it's drawing it. Let's give it just a little bit of padding here to make sure everything's cool. Cool. So what this is giving us, let me make this a little bit bigger so that it's easier to see. So we have our wave shape that's being rendered in our wave view, and the shape right now is just rendering the rectangle, the path of the rectangle of the bounds of the view that it wants to be rendered in, with a slight quarter radius. If I set this to 20, then see it a little bit better. But obviously we don't want a rectangle. We want a nice wave form here. And the way I want to do that is I want to use Bezier paths. So I might need to import UIKit in order to get Bezier paths. We'll call this path is equal to UI Bezier path, and we're going to render path dot CG path. Actually, I think I need to say path that takes a CG path. Cool. So this is empty. For right now, if we need to render this sinusoidal pattern, we need a couple of things. One, we need a resolution of the points that we want to render. So let's, for right now, say resolution, which is going to be an integer, and let's set it to 10 for right now. It's just going to be a static or a constant. And then let's give it a, let's not worry about the amplitude right now. And let's do it. Amplitude, it's also going to be an integer. And let's set it to 1 as well. So for this path, Uh, we want to we want to start the path in the middle of the view. Um, I want to start it here, at least at first, and then draw it effectively in the middle. Here, the path looks like it's being started at the bottom, but for right now, let's start at the middle. That way we can position it later. So I'm going to get the starting point. Call it start point, and that's going to be a point at the rectangle's minimum x and the rectangle's middle y. So that should be all the way to the left and in the middle of the view. So we're going to move the path to that start point. So we're going to start the path right in the middle of the view, right here. And we're going to then iterate um, over the points by a resolution amount and then draw the sinusoidal wave. So for that, we need a for loop, but how did they do that stride? So for x in stride, I'm just going to copy that for now. So from 0 through width by 1. The width, I actually want to do this by resolution. And the width is going to be, let's set up our constants up here. So we're going to have our start point here. And we're going to have width equal to rect dot width. Okay, CG float. So we'll say CG float of our resolution. Can I do that? Yep. Cool. So we're going to start at 0. We're going to go all the way through the width, and we're going to, for every increment of the loop, x is going to be increased by the resolution amount. Actually, is by the amount or is by the fraction of the amount? Let's see. So we add stride until the next value would be on the end. Okay. So we want to go by resolution divided by, or width divided by resolution. So let's do this like that. Cool. So we'll start there. And now we get to do some fun maths. For the sake of argument, or the sake of testing, let's see, do we get sine? Yeah, okay. If we did the sine of x, that would give us the y value. And so what would happen if we path dot add line to, and let's say let point equal to CG point of x. Let's say let y that point. Ooh. So it's kind of wobbling. It's up there. We might have to adjust the amplitude. Yeah, because I have a feeling this y value just is going very the range of that y value is probably pretty small. So for instance, if we multiplied by 20, okay, we're starting to get a better wave there. 50. Okay, cool. So it's getting there. Um, we need to drop everything down by the starting point. The starting point's y. So let's do this minus starting point dot y. Whoop. I need to add it. Yeah. So we've got our wave here. I want it to curve. So instead of add line, maybe we can add, might be able to increase the resolution here. Ooh, that is icky. That's strange. Huh. I guess. Okay, so yeah, that's just kind of changing the frequency. That's not necessarily the resolution. That's not really what we want. Um, what we want the is it the wavelength? Yeah. So if we have a wavelength, let me pull up a sinusoid calculator. Good old Wolfram Alpha. So if we have our sinusoid here, and we have our wavelength, calculate wavelength. Man, I should have paid more attention in math. Let's see. Oh man, this reminds me of it. It's like a math textbook. Wavelength. It's equal to the phase velocity velocity over the frequency. Um, so what I really want is like if I'm dealing with a frequency of 1 here, and I want the wavelength to be the width divided by the resolution, I think. Like I guess what I'm saying is I don't want 10 I don't want this to calculate x like at each I want this to calculate x at each point in the resolution, but I don't want it to go from like the sine of 0 to the sine of 10. I want it to go from the sine of 0 to the sine of 2 pi divided, and I want to plot that for each point in the resolution. So divided by or I guess multiplied by x over the resolution. Does that make sense? Um, me think about this. Uh, let's take a look at how they're thinking about it here. Okay, so they're splitting up the total width based on the frequency. They have a they have a frequency here, how frequent our waves should be. So if this was 1, then their wavelength is going to be the the width of the screen. That makes sense. The relative x is x divided by the wavelength. That makes sense. So what that's what I was trying to conceptualize is they have the wavelength that in my case I want it just to be the width of the screen, and then they've got their fractional value to represent like the rendering the tiny part of that wavelength from 0 to the width. So at the end of it, when x is the width, that will, like let's call this 100. If we're going to 0 to 100, it will be 100 over the wavelength, which is 100 divided by 1. So that will be 1, and it's calculating the sine of 1, the the full turn. I guess the full period. Um, I guess I don't know if that's the full period. Anyway, that's what I want. Uh, so we're going to increment this by 1. We're going to have our, let's call it relative x similarly, which is x divided by wavelength. Let's have our wavelength equal to the width divided by frequency, and we'll just go ahead and set equal to 1 here. And then want this to be relative x. Float. Okay, so that's much smoother. The I want this to be, if I want a full period, then this probably needs to be times 2 times, is there pi? Math? Import math. Okay, 3.1415. There we go. So if we want the frequency here to be normalized to like a single one, or a single full period, then we have to do a little math. And I'll just do it up here in the frequency, whatever. Now, like we want this to be shifted over. So actually what we want is more like cosine. Yeah. And we want this to be, if it's going down, I think we only want it by half of the starting point. So actually, let's have the starting point. What happens if I get rid of starting point? I wonder if we'll start at the. Will it start at the beginning? No, probably not. Let's have the starting point be the, for right now, how do I want to do this? If I want to, is this okay? Yeah. Like, do I want to effectively say something like, um, if x is 0, then make the starting point? Like, do I want to do I want to do something like this? Start point equal to min x and then y. Continue. Nope. And then I want to do this. Oh, I have to calculate relative x first. Like that. And then rely on the offset. Like push it down with like an offset property on the wave, or do I always want it to render in the middle? I probably always want it to render in the middle, and so let's start with that. Let's go back here. So if I'm here, I will drop it down. So if I don't offset at the beginning, it's going to try to render up there. I want it to start actually want that. Do I have to move to the start point first? Or will yeah, I have to give it a starting point to render. I don't want it to render this first line though. So maybe if I just move it to that point first. Yeah. So here's what I'll do. Instead of adding the line there, if x is 0, we'll move to the point. Keep going. Not start point, just regular point. There we go. So there's our waveform. Whew! Man, that took longer than I expected. How long was that? 28 minutes. Okay, so only 28 minutes to remember high school trigonometry and get it all set up just to render this curve within our view. But we have a curve now, and it looks very similar to the curve that we have in the mock. Now that we have our curve for our wave in this shape, we can start to overlay additional shapes on top. So for instance, we have a rule here that goes through it that I think I can just render with a line on top, and then we have a point over it. So if in our, instead of a V stack, let's do a Z stack. And I just do a line. I might have to do like a rectangle of frame height 1. I mean, it's close enough. So I've got the horizon effectively rendered on top of it, and we need to now draw a circle. And the circle needs to follow this path. And the way that we can do that, we should render it on top. got our circle here, and let's make the frame the width of was 10. It's yeah, it's good enough for now. 10, but we want to position it along this curve. So to do that, we might I I think maybe we can ask. What if we can ask the wave for the the point along its path? Like, what is the position along your path? That way we can keep these two views in sync. The kicker there being that the circle needs to ask that of this wave. That's okay. What we can do is let's add a static function for now. And we'll say point in cgrect. And we effectively want to do this calculation. So let's do, we need the frequency, we need the width, we need the wavelength. And then we need to return CG point of x and y. X is going to be point in rect. Let's give it a, we probably want to pass it, an x. So let's say that point for x, and that will be a CG float in rect y, and we'll say let y equal to, I guess we can just reuse this. Relative x is equal to the wavelength here, and our starting point, the y, which is just rect dot mid x. I'll need to generalize that, or I'll need to pull that out so that we don't need to keep track of both of them. So does this work? I wonder if this works. Let's give it a shot. So frame 15, position the center. Okay. Wave dot point for, let's say, x. Let's do the middle for now. Here, we're going to need our handy geometry reader. So we'll do a geometry reader with a proxy geometry proxy. Whoops. And for proxy dot, or say proxy dot, oh, oh no. My monitor's, my monitor's freaked out. Hang on. 1 second. Oh no. Come on, monitor. Okay, we're back. Um, so proxy dot size dot get mid no width divided by 2 in proxy dot rect mid y. Yeah, I'll give it the the container use bounds rectangle converted to a defined coordinate space. Let's say cgrect origin. Oh, it's getting along. 4 in. Let's start with the 0 point. I don't know if this is going to work or not. Ah, perfect. It actually did. This didn't. This got shoved up to the top. I guess because it's aligning everything up at the top. I'll need to shove that down. But this is neat. If I do this 5 by 3, 4, 5, it looks like it's following the path. Does it work for a 0? Cool. And then proxy dot size dot width at the end. Yep. So now we've got a dot that we can place along the curve. Let's pull that rectangle down. Frame height, position. This is the middle point of the rectangle. So I want CG points at basically this rectangle's middle. Say CG point x, which is proxy dot size dot width divided by 2, and proxy dot size dot height divided by 2. There we go. Entered in the middle. All right. So it's ugly, color-wise, but we actually have a wave view that can render things, which is neat. Now, let's style it and let's dump it in our sunset, and we can play around with it. And see if this thing even, like how it looks. So for instance, if I go and I create a V stack, can I put 2 of these? What happens when I put 2 of these things in here? Okay. That's actually what I would expect. And if this is an H stack, ooh, what does that look like? It's not great, but just won't put. It looks fine. Cool. All right, so we have our wave view. We have our sun tracker view here that we're actually going to put our wave view in. let's get rid of this progress view. And what happens when we put in a wave view? Not terrible. Um, it's not great, but it's actually not terrible. It looks like the things are being rendered backwards than I expect. Like I want the line to be above those. Uh, so is that how it's currently? Why is that rendering backwards there, but it's rendering? Huh? It's kind of weird. Huh? That's weird. I wonder why it's doing that. What's kind of neat is it looks like is it pulling the foreground color from that? So say foreground color green. Oh, okay. That's kind of nice. It's using the foreground color as the default, I guess, color on that. It's it's kind of cool. But I don't like that it's being rendered behind it. Let's. Okay, now now it's not. Whatever. Um, okay, let's let's configure this um, by giving it a like a what's the word? We need a like sun, like a day color, night color. Let's do that. So here, say day color, night color, and we're going to render the, let's render the wave in night color. And day color will say white, and night color dot, we'll say blue and green. Is it because you didn't like this? Okay, but the, oh, actually, this is could be more accurate. Yeah, blue and green, but we're actually not rendering the thing there. Let's render the foreground color as day color. But we want the top half of this to be rendered as green as well. And to do that, I'm not 100% positive on how to do that, but one thing we could do is apply like an additive blend to this part. Like if we overlay a, oh man, my monitor, does it keep doing that? If we apply a like a almost like a layer on top, a shape on top, on the top half of the view, and we tell SwiftUI to blend that layer, which should be I don't know if we could do this, like an invisible layer, but blend everything behind it with a different color. You get what I'm saying? Like if we have a pretend there's a rectangle here that all of the all of the contents underneath it are rendered a specific color. And we can use that with like maybe a blending mode. And then we insert that layer on top of the curve, but underneath the dot. I wonder if we could do that. Um, Let me see. Might have to do some Googling here. Um, let's say SwiftUI blend modes to combine overlapping views and use a different visual effect to produce the result. That's kind of what we want. Wrap this view in a composite group, drawing group, blend mode. Oh boy, it's going to be interesting. Destination over. There's probably a better description of this. Color blend modes. Blend modes explained. Yep. Um, I need to play around with this actually. Um, yeah, we'll probably just need to play around with it. But like, how can I even accomplish this? Let's see. Blend mode. Use blend mode to combine overlapping views and use a different visual effect to produce the result. The blend mode enumeration defines many possible effects. Okay. So in the example below, we have two overlapping rectangles, but blend mode color burn, which effectively removes the non-overlapping part of the image. That makes sense. Oh, which removes the non-overlapping part of the image. That's kind of what I want. That's almost exactly what I want. So it looks like color burn. Okay. So color, red frame, width, height, alignment, center. Let's try that. Let's see if we can do that here. So I want to have, we have the wave, we have the rectangle, and then we have our circle. In here, like what happens, okay, we'll say color dot, we'll say day color, and we'll say dot frame of width is going to be proxy.size.width. Height is going to be half of the height. And then we want to blend dot color burn. Nope. I wonder if it only does that with two colors. Two overlapping views. I mean, they are overlapping. Center padding, blend mode, color burn, right? It's overlapping, right? Um, ooh, I wonder if this is because, is that because it's stroked? Look at that. Hmm. Hmm. But even then, if this was working the way I would expect it, I would expect this top half to be above it. What? Maybe because it's not exactly overlapping? Nope. What are the different blend modes? Blend mode, darken. Hmm. Dot color. Nope. Dot overlay. Nope. Dot source atop. Me. Nope. I mean, based on the description, the example here, this is exactly what I want, but maybe it's just something having to do with how my wave shape is being rendered. Composites this view's contents into an off-screen image before final display. Hmm. Compositing views. Wraps this view in a compositing group. Hmm. Let's do some more digging into this. Using blend modes SwiftUI. Actually, we'll say blending views SwiftUI. Oh, very simple. Uh, ZSAC. Placing view over another, you can control the way they overlap by using the blend mode. This contains a variety of ways you can mix colors together, such as using their difference or using a color burn. From every using core graphics. Okay. Second one as a multiply, darkens the colors behind it. So what does this look like, for example? Huh. What? What? Doesn't make anything. Huh? What's going on? What? Nothing? Nothing? Okay. Uh. Oh goodness. Okay. I mean, like that's what I want. It's kind of what I want. Ish. Like I want the view on top to disappear but have an effect on the color of the shape below. Know what I mean? But for some reason, it's not affecting this wave. What blend mode was that? Screen? Hmm. Surely the geometry reader doesn't matter, right? So for instance, if I were to give this a wave, oh, it is doing it there. Uh, hello? Oh, uh, let's make this blue. Green. Okay, like that's, oh, huh. Color burn doesn't do it, but screen does it. Hmm. Okay. Screen. Okay. That's that's the effect that we want, but we don't want the screen effect. We actually want it like we want it to be just straight up the color. Uh, let me. Okay, here's what we can do. Um, let me do a. Let's do this. Do this little Z stack thingy. We'll do it in a V stack. Shove it up in the top. Nope, in the middle. Whatever. Uh, we'll put this in a scroll view. Cool. And then like this. Um, we will kind of iterate through all these. Blend mode dot. I wonder if I can do that. Iterate through enum Swift. It's got to be iterable. I don't have that. I don't think that's iterable. All cases. Nope. Ah, that's not cool. So blend mode. Let's look at the definition here. Okay. I wanted to get the docs here for blend mode. Blend mode.screen. Normal, darken. Just want to iterate through all these. Makes the color prefer. Lightning, darkening, normal. Well, we'll just go through each one of these one by one and see what we get. So first one, normal. That's not what we want. Darken. Nope. Multiply. Nope. Color burn. Oh, it was there for a hot minute. What happened? Dot color? Huh. Oh, that mixes. That's actually a. It's actually a value. Um, we have plus darker. There's lighten. Then there's screen. There's color dodge. There's plus lighter. There is overlay. Then there's soft light, hard light, difference, exclusion, hue, it's close, saturation, color, luminosity. So this is mixing source to top, which we've already seen. I don't believe that does anything that we want. Destination over. Destination out. Nope. Okay, so I feel like color burn was what we want. For some reason, color burn isn't working. It's not doing the thing that we expect. But color is close enough. So I'm gonna go ahead and just roll with color for now. It's not gonna be exactly the style that I want, but it's close enough, and I can spend more time on this later. For now, this is generally what I want. We have a nighttime color, which is the bottom portion of the track. We have a daytime color, which is the top portion. Um, we have a dot for the sun. So let's say sun color here, and that will draw foreground color is sun color, and then here we'll say you are for now. Let's make it yellow. This is gonna look gross. And we'll do this in here as well. Wave view. Yeah. It's not great. It's also got sort of a glare to it, so let's blur it. Um, Actually, it's not blur. It's more of like it's like a shadow. Give it a shadow of 5, 4, and it's also got a sun color, but there, it's close enough. That is close enough. We'll roll with it. Now, in our sun tracker, oh, what? Huh? That's not what I want at all. Huh? Why is that different? You you look like this. you look like this. Is that because there's a background? Um, no. No. Oh, it's doing it on top of the background. It's doing like everything underneath it. Oh, I don't want that. I just want it to blend specific groups. Oh. Oh, no, 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 no. Okay. Maybe that's where that composite group comes in. Uh, blend mode, composite view, Swift. Everything underneath that view. Okay. This is actually really helpful in terms of the individual modes. Okay, you apply multiple blending modes, different layers. Translated OCA composite filter. Oh man. Let's see. Applying multiple blend modes. Applied, discarded, discarded. Let's say SwiftUI apply blend mode specific views. Hmm. This is actually really helpful. Oh my goodness. I'm gonna save this. I'll put this down in the description. Wow. It's not helping me though. I don't want it to apply the blend mode to everything underneath it. I just want to apply the blend mode to specific views. I want it like I want to halt the blend mode. Uh, let's take a look at compositing group. Wraps the view in a compositing group. Okay. Composites this view's contents into an off-screen image before final display. Maybe that's what I want. Drawing group. View that composites this view's contents into an off-screen image before display. Just opaque. Discussion. The drawing group modifier flattens the subtree of views into a single view before rendering it. I think that's what I want. Compositing group. Let's try that. So for instance, red. If I flatten this, compositing group dot drawing group composites. This views content off screen before opaque. False. Color mode. Man, I have no idea what I'm doing. I just don't want, I don't want this. Um, Why is that? Why are you here now? Interesting. Interesting. Um, Here's a question. Hmm. Let's see. Let's see. Hmm. There might be something there. I don't want to give up on the blending mode just yet, though. Okay, we've been going for a while. I'm going to go ahead and cut it here. When we get back, I'm going to think about this a little bit more. And next stream, we'll get to the bottom of this. Um, Thanks for everyone for watching. Again, if you want to see all of the replays of this series, go to youtube.com/let's build with bits because Twitch likes to only keep VODs around for, I think, a week or 5 days. So if you're coming in late and you want to see more, head over to YouTube and you can see the whole series if you want. We'll stop here. See you later. Thanks.